Now we're asked to find the equation of the plane that's perpendicular to the two components of the acceleration vector. Okay? So it's perpendicular to velocity and acceleration. Well, unless the velocity and acceleration happen to be parallel, then we can take the cross product of those two vectors. If they do happen to be parallel, in other words, if you're moving in a straight line in three-dimensional space and not deviating right, left, up, or down, then your velocity and your acceleration are along that line, and there is no unique plane. There are infinitely many planes perpendicular to your velocity. Okay? Now there's still a limitation on where those planes could be, but let's assume that your velocity and acceleration are not completely parallel, because if they aren't, the situation's not all that interesting anyway. Okay, at least mathematically. You know, if you really got to fly that straight line, then it is kind of interesting to be able to do it. But the plane perpendicular to your motion, you can roll any way you want to, and you're still on the same line. Okay, so your normal is just going to be the cross product of your velocity and acceleration. Now, if you had a unit vector in the direction of your velocity and a unit vector in the direction of your acceleration, excuse me, then that would be okay. And you know, I really don't want to use n for this vector anymore. It's really not the n vector, because usually in this context, the velocity, or the component of the acceleration perpendicular to the velocity, is the vector that's going to be normal to your direction of motion, and then you have a vector that's perpendicular to both of these, which is called your binormal, and usually designated with a capital B. So I'm going to introduce that terminology. From the context of the problem, there's no reason that you would have thought about a binormal. You could have just thought about a normal vector. And that's actually the way I wrote it down, but I'm modifying that slightly. Okay, so you could do v of t times a of t, or you could do the unit tangent times a of t, or you could do the unit tangent times perpendicular component of a of t. You could even do unit tangent times the magnitude of the perpendicular, times the unit vector in the direction of a of t, which would be our n of t vector. So let me try to avoid confusion by this. Okay, so here's kind of a picture. We have our velocity vector, which is our r prime vector. We have our unit tangent vector, which is this one. Okay, that's a unit vector in our direction of motion. We have our perpendicular component of the acceleration. Well, we have our acceleration vector, and we have the component of the acceleration parallel to our direction of motion, which is just the dot product of the acceleration vector with our unit tangent vector, as we've seen. And we have our perpendicular component of the acceleration, and we see that the perpendicular component and the parallel component add up to the acceleration, so the perpendicular component is just the acceleration minus its parallel component. Okay, and I've got arrows over these. When I talk about the parallel component, I could be talking about the magnitude, or I could be talking about the vector component, and here with the arrow it's implicit that I'm talking about the vector component. Okay, well, what's the plane through r of t normal to our and that's not right, so let me fix that. Okay, first place, r of t is a position, and I haven't indicated r of t here. Now there's no error in having written that down, but if this is the origin, then here's r of t. Okay, when I say a plane through the point r of t, I mean a point through the point, a plane through the point at the tip of the r of t vector, assuming r of t is rooted at the origin, assuming that its initial point is the origin. Okay, and then I want that to be normal to v of t and a of t. And again, I can calculate that by v of t cross a of t, obviously, by t of t cross a of t, because t of t is just parallel to v of t, and in the same direction, or t of t cross a perpendicular of t, because in taking the cross product of our unit tangent with the acceleration, it's only the component perpendicular that determines that cross product. The component parallel, when it's crossed with t, gives us 0. So this would be sufficient. Okay. So what's the plane? Well, once you get t cross a, which you can calculate, and I do note here, t cross a is t cross a parallel plus a perpendicular, since the a vector is a parallel plus a perpendicular. That's t cross a parallel plus t cross a perpendicular, and a parallel is parallel to t by its definition, so that's 0, and you're just left with t cross a perpendicular. So again, this is the justification for this. So we want the plane through r of t normal to these. And I'll simply comment, I want to say simply component, I'll simply comment that this is easy. Once you've got v and a. So we didn't complete this. And there was another problem in the problem set, in the quiz, that asked you to find the derivative of this binormal vector. Okay? Not for the faint of heart, but it's something you, again, would be expected to be able to take the derivative of. There's only one nasty denominator, and actually you don't even get a denominator. Okay, I just realized I have another little glitch here. The binormal vector is, so you do have a nasty derivative. Now, you weren't actually asked to calculate the binormal. You're just asked to calculate a vector in the normal direction. You weren't asked to find a unit vector in the normal direction. But this thing is a unit vector in the normal direction. So then you would have this over the magnitude of a of t. Okay, because, of course, magnitude of t is 0. And this would be over the magnitude of a perpendicular of t. So, apologize for the oversight, but we haven't really defined this. Just giving you a little hint of what's coming. In any case, once you've calculated any of these vectors, whether you divide by the magnitude or not, you have a normal vector, and you can find the plane, because, of course, to find the point r of t, you just take your given value of t, or just take your symbol t, and put the components of these as coordinates of your point, and then you're pretty much home free. You can just write down the equation of your plane.